today we're going to do fundamental theorem of algebra again, but this time I'm going to formally write down what the fundamental theorem of algebra states. And okay, in connection with that, we also have another theorem that says linear factorization. So first, the fundamental theorem of algebra. Okay, it's telling us if you have a polynomial of degree n, okay, where the n is greater than 0, that means, okay, it would be the degree or the exponents are 1 up, then your polynomial has at least 1 0 in the complex number system. Okay, which means that it can also be real or imaginary. So it can be real or imaginary. So that's what's new for today. We're going to do real zeros and imaginary zeros as well. So the linear factorization theorem is the one that I kind of already told you last time. Because if your polynomial has a degree n, then you have also precisely n linear factors. So if your exponent is 4 power, that means you're going to have 4 factors. That means you're going to have 4 zeros. So that's what you call linear factorization theorem. So find all the zeros, but this time we're going to have imaginary as well. Okay, so for number 1, they're giving it to us in factored form already. So we're going to write down all the zeros. So if your first factor is x minus 1, what will be our first zero? It will be x equals 1. So all you need to do is to just put it equal to 0 and solve for x. So all it does is to change the sign to the opposite. Okay, so if your factor is x plus 2 squared, then what's the next zero? It will be x equals negative 2. But what do you notice about the exponent? There's 2 of them because it's second power. So you're going to write down the negative 2 twice, okay, because there's 2. But if you're asked to graph it, then we're just going to write it once, but we know there's a multiplicity of 2, which means that you're going to touch only the x-axis at negative 2. It's not cross. X equals 1 is cross, x equals negative 2 is touch. Then we have the imaginary. So we're going to do it the same way. X minus 2i, put it equal to 0. So that means x is equal to, all it does again is to change signs. So that means x is equal to positive 2i. So your fourth zero then is positive 2i. And last but not the least, you have x plus 2i, which we know is just going to change signs. So that means x will be negative 2i. Remember, all it does is to change the sign to the opposite. So your last zero is negative 2i. Now, if you look at all the exponents, this is 1, 2, 1, and 1. So if you add them up, that's 1, 2, 3, 4, 5. And if you count the number of zeros, that's also 5. 1, 2, 3, 4, 5. According to the linear factorization theorem and the fundamental theorem algebra, there will be 5 zeros because the highest exponent is x to the 5th. Okay? So, now if you also look at the ones that are imaginary, 2i and negative 2i, what do we call those that are exactly the same but they have opposite signs? Complex conjugates. Okay, they are complex numbers. Okay, the imaginary numbers, they will always come in as complex conjugates. In other words, they always go together. So if you have a positive 2i as one of your zeros, automatically negative 2i is also one of the zeros. So I'm going to put here a little note, okay? Oh, right here probably. Imaginary, always complex conjugates. You can't have one without the other. Like, okay, always complex conjugates. You know what I'm talking about, right? Oh, never mind. Maybe you don't know. It's that Love and Marriage, Love and Marriage. Do you know that TV show? No? No. Never mind. Alright, so complex conjugates always together. All right, so let's do number 2. So your zeros then are, okay, these are the answers. Now look at number 2. Ooh, there's a bunch of them, okay? But we already know the trick. All it does is to just change the sign to the opposite. So zeros. Take x plus 1 to the second power. Okay, it'll be minus 1. X equals negative 1. How many negative 1s?
2.
There's 2 of them. Then on the x minus 2 square root of 3, what will it do? X is equal to? Positive 2 square root of 3. So the next one is 2 square root of 3. Then, what about x plus 2 square root of 3? It'll be negative 2 square root of 3. Then we have the imaginary numbers. Uh-oh, how do we do that one? Remember, all the signs changes. So if it's x plus 1, then that means negative 1. And if it says minus 2y, that means positive 2y. Okay, so I'm going to write it down right here, okay, so that you know why it will work. Why changing the signs always work. So if we're solving for x, take out the positive 1, and we take out the positive 1 by subtracting 1 from both sides. So this will cancel. So that means all we have left is x minus 2i is equal to 0 minus 1 is negative 1. Then we are solving for x, so we need to get rid of 2i as well. So you're going to add 2i to both sides of the equation. And you cannot combine these two because one is a real number, one's an imaginary. So all you need to do is to just put it in standard form, which is real number first and then the imaginary. And that's why it's going to be negative 1 plus 2i. So it will always work. Just change the sign to the opposite. So if our last factor is x plus 1 plus 2i, what will it be? Negative 1 minus 2i. And you can solve for it by putting it equal to 0 and just doing the opposite sign always. Okay, so your zeros then are this. And of course, the complex conjugates, negative 1 plus 2i and negative 1 minus 2i will always come together. You cannot have the other one without the other. They always come together. Okay, so number 3. Okay, find all the zeros again. So that means we're solving for x. X squared minus 4x plus 1. You already have a quadratic. So first thing that you do once you have a quadratic is to do the factoring. So let's see if we can factor it out. We have positive 1 that adds up to negative 4. Is there any factors of 1 that will add up to negative 4? No. So that tells you you cannot do factor. You cannot factor. So what you need to do is to just do quadratic formula. So I'm going to put here cannot factor. So we're going to use the quadratic formula. So use quadratic formula. So, okay, quadratic formula again. Okay, it's from the past lesson. Okay, so it's x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Where your b squared minus 4ac gives you the discriminant. It tells us if we're going to have 2 real numbers, 2 imaginary, and so on and so forth. So our a, it's already in standard form. So our a is the number in front of the x squared, which is 1. Our b is the number with the x, which is negative 4. And our c is the number by itself, which means it's 1. All we need to do now is to plug it in. That's why we did that lesson before. Okay, we went to this one because you're going to have to do quadratic formula. So plug it in. So it's going to have negative, and then plug in the b, which is negative 4. Okay, plus or minus square root of, it's negative 4 for the b. And remember, that will always make the answer positive. So it's not going to be negative 16. That's positive 16. Minus 4 times the a number, which is 1, times the c number is 1 also. Then in the bottom, you have 2 times a, and our a number is 1. So once we do this, let's simplify. So this will give us positive 4 plus or minus square root of 16 minus 4. Because 4 times 1 times 1 is 4. And that tells us right away it's not going to be negative because it's 16 minus 4. So that means we have two real answers. No i's in our answer. Divided by 2. But, okay, we still need to simplify. So you have 4 plus or minus square root of 12 divided by 2. And, okay, you could tell that we're going to have to simplify because there's a 4 and there's a 2 in the bottom. And square root of 12, we can also simplify square root of 12. What perfect K number can we use as a factor of 12? 4. So it's going to be 4 times 3, and square root of 4 is 2. So that means it's just going to be 2 square root of 3. Okay, don't forget to simplify your radicals. Okay, so putting it in, 4 plus or minus 2 square root of 3 divided by 2, and I could tell that we need to simplify. So just simplify. I'm going to put them separate. So 4 over 2 plus or minus 2 square root of 3 over 2. And then I'm going to simplify. So it'll be 2 plus or minus. And remember that will just cancel. So it's just going to be square root of 3. We're supposed to have two answers. What are the two answers? The one was positive and the other one was the minus sign. So 2 plus square root of 3 and 2 minus square root of 3. So the zeros are, because we're asked to find the zeros, so we write our answer as zeros. So the zeros are 2 plus square root of 3 and 2 minus square root of 3. You don't need to write them separate. Okay, if you just write 2 plus or minus square root of 3, that's also correct. Okay, I just want to make sure that we're counting. There are 2 zeros. All right, number 4. Number 4 is already quadratic, so we don't need to do our synthetic division. Okay, if it's down to the squared, okay, factor or just solve. Okay, in other words, using quadratic formula. But look at number 4. What's missing? The x, right? If you are missing the x, if you're missing the x, you don't need to do quadratic formula. This is even easier. All you need to do is to just put it equal to 0 and solve for x. So since the x is missing, okay, you don't need to do quadratic formula. If you do quadratic formula though, you're going to get the same answer. But, okay, all you need to do is to just put it equal to 0 and solve for x. So all we need to do is to just take out the 9, put it to the other side, and then we're down to x squared by itself on one side. And to get x, the squared out, what do we do? Square root. So this will give you x is equal to, and what do we put in front of the square root? What do we put in front of the square root? Plus or minus. Remember, it's always positive, negative. Plus or minus, square root. And then the negative 9 in the front. And what do we learn about negative numbers inside the square root sign? It will be imaginary. So this is when you're going to come up with imaginary zeros. So that means x is equal to plus or minus square root of 9i. Okay, which we can still solve. Square root of 9 is 3. So this will be x is equal to positive, negative 3i. And those are the two answers. So zeros are, okay, it's the second power, so that means we're going to have two answers. One is positive 3i, and the other one's negative 3i, which are, of course, remember what I said about imaginary. They always come in as complex conjugates. That's why if you have a positive 3i, negative 3i is also automatically an answer. Okay, they always come in pairs. Okay. You cannot have negative 3i without the 3i. You cannot have 3i without having the negative 3i also. They always come together. Okay? So, the one in the back, we're still going to be doing the same thing, just okay, finding the zeros. But also at the same time,